Hello and welcome to the Still Unsponsored podcast. I'm Chris.
I'm Zach.
How do you want to be introduced?
I'm Elliott, Chris's younger brother.
That's what you want to be known for. Yes, is the answer.
I don't know, man.
Okay. What do you do for a living?
I am a data scientist up in the Portland, Oregon area. I mostly do work for a huge tech company in their R&D division, but technically...
Thou shalt remain nameless.
It shall remain nameless for now. You can probably figure it out if you do some Googling. But mostly I do work for them, but technically I'm employed through a startup called Interject Data Systems, and we are awesome.
Well, there you go.
Sounds awesome to me.
This was a great episode already.
Yeah.
I've really sold it.
Okay, so last night, Saturday night? Friday night? Friday night. You're in town for Thanksgiving.
Yeah.
We're recording episode 10. We said
this is the episode 10?
This is the episode 10. Well, we could release it as like episode 11 or something.
This is kind of a letdown.
We could just skip it.
I don't have wine.
I'm let down. I have beer at least.
Yeah, Elliott's got beer. Zach, what are you drinking?
iPhone.
Nothing. Okay. So
Episode number TBD.
Episode number TBD, probably 10. Damn it. We're having audio issues as well because Elliott's microphone's crazy. All right, so we were sitting at dinner a certain number of nights ago that we can't exactly remember because we've been drinking a lot of wine. And I was asking a lot of questions about attribution vendors. So this is like the new hot thing in the marketing world, which is like, hey, we're gonna roll out a analytics platform that's going to be on top of your analytics platform, that's going to go beyond last click attribution and tell you what you should actually invest in. Yes.
Yeah.
Yeah, which no one actually heard that because it was probably just like on the other end.
Yeah.
You could also try talking into the front of the mic.
God damn, play this shit again. Motherfucker.
Recorded live, everybody.
That's better now?
Yeah, that's better now. Okay, so my big questions were, how does that freaking work? And is this just magic / snake oil? Because I kind of thought it was. And I think that what we can do is probably in the space of about 30 minutes, distill this down into like a marketing manager's buying guide for an attribution vendor. And the questions that you should ask, to make sure that your vendor is not full of crap.
You picked a good one.
Because I know what I'm talking about. No.
Elliott knows what he's talking about on this particular topic.
Well, I guess caveat there. I don't know too much about attribution vendors. However, the way they were explained to me, I can make guesses at how they're building their models, and based off of how their models are built, if I were shopping for an attribution vendor, I would have certain questions.
Okay, so let's for the broad base of listeners explain what theoretically what an attribution vendor is supposed to do. So they're supposed to take as much data as possible, like all your analytics data, any data that the vendor itself might have access to, all of your spend data, and build you an attribution model that says that it wasn't actually your brand terms or your retargeting that converted this customer. It was upstream, some traditional media that you bought, or something else. It was actually the display prospecting or whatever. And my thoughts were, well, if you had incomplete data sets, how would you do this? Is this just magic? Or like what is actually happening behind the scenes? So what is actually happening behind the scenes, if you had to guess?
So based off of the way it was explained to me, I would guess that what they're doing is they're running some sort of classification model that essentially takes a input set of attributes or fields and guesses as to what type of class it is. Is it a click type class? Is it a link from vendor X, vendor Y, vendor Z. And so classification models typically fall under what's called supervised learning. Supervised learning means that essentially you take your data set that you have really well curated and you hide and mask the class in your data set, and then you create a training data set, and you train your classification model with the training data set, and then you test it with your test data set to see how accurate your model is. So the first question is it a supervised classification model? If they say no, then the question is, well, maybe Elliott got it wrong about what type of model they're using. But if they say it's unsupervised, it's snake oil. Don't buy it.
Why would it be snake oil?
Because they have no way of cross-validating their answers. So they can make up any sort of number, and they could be doing a whole bunch of things like overfitting their data and having all sorts of problems.
So
really
basically, this would be like bare knuckle drug testing, where you're just like, you're not having a controlled set. You're just like giving drugs to people, and if it seems like net it works, then you're calling it a success.
Yeah. So the example is that it's the false positive rate versus the true positive rate. And so what you want to know is how many times so the classic example is a pregnancy test. If I go up to a male human and I say, congratulations, your pregnancy test comes back as positive, that's a false positive. Because it's biologically impossible.
Has that happened to you, Zach?
I can't say that one has happened yet.
But the point is that a lot of models need to tell you, yeah, you have a false positive rate of X. Those will that will exist, and that's okay. The point is that you understand how much is there. And so what this boils down to, I think the big takeaway that we had in our conversation is that there's this thing called an ROC curve, which is a receiver operating characteristic curve. And it was invented by the US military during World War II with essentially their radar technicians, when radar was still kind of a quiet thing, to be able to say the signal that we're seeing is actually an enemy plane versus
noise.
It's just noise.
Mm-hmm.
And so ROC curves are extremely simple curves that essentially, the closer they, it has an XY axis. On the Y axis, it's true positive rate. On the X axis, it's false positive. And then a straight line means you have a really, really bad model. A line that is curved towards the 0 on the X and up, so it's really left skewed. Left skewed isn't quite right, but I'm trying to paint a picture with words.
You're trying to describe in audio something that took you a master's coursework on a marketing podcast.
Yes, exactly. So forgive me, I'm sure there are data scientists out there listening going,
probably
that's
not.
No.
Okay.
No.
Well, again, I'm trying to explain this and I am doing a poor job, so forgive me. But the point is that you can Google ROC curves, and if your vendor, who is essentially selling you an algorithm and selling you a model, won't show you an ROC curve or a cross-validation model or something that essentially tells you how good it is at picking out false positives from false negatives, from true positives, from true negatives, then there's zero confidence in trusting the model they have. And it probably means they didn't vet it. There is kind of, just to ramble here, there is kind of the flip side, which is if you go and ask these questions to people on Wall Street, they won't tell you either, because their models are so much intellectual property.
Let me ask you this. So the ROC curve, is that going to be for each client, or is it going to be for, because a Wall Street person wouldn't tell you theirs because they're trying to use their proprietary algorithm to predict the market or something, right?
Yeah.
But these vendors are basically, essentially, the Wall Street analogy might be build new asset classes for every, for every client. So every client should have a different curve?
Yes, but if they're making the sale to you, they probably don't have your data yet, and so they probably can't give you one for your data. So ideally what they would have is they would have an ROC curve case study or a white paper that was like, look, this is our flagship client that you can email and ask questions to, and this is what their curve looks like. This is how we cross-validate their data. This is our sampling strategy. This is how we, another important question that's also case by case is this is how we vet the data that builds our model. That is something that is more of an art than a strict science.
Okay.
But again, that's one of those things where if you're having that conversation with your vendor and your marketing manager, maybe bring in a data engineer with you or a data scientist if you employ one, to kind of feel out the way they handle eccentricities in your data, because all companies have eccentricities in their data. And
I think we could pretty safely assume that, well, okay, so this is where it gets tricky, right? Because we're an attribution vendor, you're probably talking about someone that's willing to plop down, $200,000 a year for this service, right? So that means that, you're probably spending a couple mil a month on media or whatever. So that's definitely a like high class thing. So maybe they do have data engineers, maybe they don't. And the data engineers might not necessarily be familiar with the marketing side.
Yeah, I think that the point is that if you don't have somebody who's familiar with how these models are built, a data engineer will kind of at least be able to raise a red flag of like, whoa, that's not the shape of our data. A good data engineer, or even just like an analyst, should have a gut instinct of like, yeah, our data doesn't actually look like that.
Okay, so what about other bullshit detectors? Like, should they have patents or proprietary information? Or like, if you ask, or if you ask like, what is their system built on? Like, would they know that information?
They would. I don't think that that's quite as much of a detector right now, because I've seen in the Portland area a lot of kind of startups be like, oh, we can do these sorts of things, not particularly in the marketing space, and they're built off of the same data science platforms of TensorFlow or SciPython or an R stack. All of those exist. Most of them probably they wouldn't patent anything. If they did get a patent, that's kind of weird. A lot of it, in my opinion, a lot of it is something that you don't ever want to patent if you have, because you don't want it to be released in 10 years. You want it to be held forever. It's intellectual property that is so secret that nobody knows it.
So back up a bit. So you kind of threw out a couple, 3 kind of major platforms or stacks. So it sounds like a lot of these attribution vendors are kind of using baseline software, intelligence, whatever, and then almost throwing crap on top of it. Is that accurate?
In my opinion, I've seen a lot of, quote, data science companies who use a lot of different stacks. There's more than just 3. I just mentioned 3. And they just throw crap on top of it. So my philosophy on it is that what separates a script kiddie, if you will, from a data scientist or a true data professional is somebody who understands the randomness within your own data set. And so that means controlling your cross-validation, understanding your ROC curves when you're doing classification, understanding how the noise in your data sets occur, and also understand sampling, and that sampling innately has noise in it. For example, there are a lot of companies who are just like, well, I threw my data at this model and this model didn't work. It's like, well, yeah, because you were using the wrong sampling techniques. You weren't doing what's called bootstrapping or bagging or random forests or etc. And what this means is that they spend a lot of time on this model part, but I would say 90% of getting a good model isn't actually writing the model, because those are pretty well defined. It's cleaning your data and understanding the shape of your data before you put it into a model. And this is actually kind of where we came to our conversation a few nights ago, is that if I was running a company that I knew had a really high ability to classify data based off of attributes of somebody, I'd be charging a lot of money for it, because that means that my source data is excellent, and that would be very, very expensive to produce.
Interesting. So in that vein, like thinking about like okay, if the end goal is to be able to tell you like what the true cost to acquire is of a customer, knowing like as much information as possible, like one of the arguments that we've had is, should you trust someone like Google to tell you? Because on one hand, they have a shitload of data. On the other hand, they may be biased. Or a third party that may be independent because you're just paying them. Or like, but the downside is they don't have access to like the network of data that that a Facebook or Google might.
Yeah, so and I think that depends on, again, your specific use case and what you're actually looking at. A company like Google or Facebook might not actually be building a model. They might just have the data, right? They might just know, oh, if they click this link, it comes from here, and because we own the entire data pipeline, we know exactly what everything is.
So then there's no false positive because...
Exactly, because it's just like balancing accounting books. It's very simple. Yeah, they probably would be biased, but they're also...
Well, because they're going to build a model for everything else.
Yeah.
And so what they could say is they could say, we are not going to allow any false positives, which would still bucket a bunch of stuff into an other category because they would bucket it other rather than saying, actually, we're going to assign attribution to someone else.
Yeah, exactly. And actually, that kind of gets to one of those key points of like, if you just ask your vendor, how do you know if it's a false positive or not? I mean, that simple question should lead into this conversation of how they're cross-validating and training their data sets and how they're using ROC curves. But if they're using the model I suspect they're using, but that's neither here nor there. But that simple question should lead into a whole bunch of technical vetting. And if they don't have a clean answer for that, then I would be very scared. And I've seen a lot of people not have clean answers to that.
So the answers are, the like buying guide would kind of boil down into like, into how does your database learn, and tell me about your false positives.
Yeah, essentially, how do you know something? It kind of gets into philosophy there, but there's a lot of money spent on that, and that's why Google and Facebook are Google and Facebook, because they spend tons of money knowing what they know.
Yeah. Awesome. What else are you thinking, Zach?
This is so cool stuff. I have nothing to add.
All right. Okay. So now we could end it right there, and I didn't ask you this ahead of time, but you did some really cool work, for your, like, what do you call it? Your capstone project or whatever.
Yeah.
Do you want to talk?
Which one?
The reversing out privacy.
Oh yeah. So
do you want to talk about that first?
It gets really nerdy really fast.
Okay,
I'd probably put your audience to sleep.
But I think that at least who's listening right now, if they are in the marketing field, they are on the nerdier side, because so are we.
Okay.
If they're still listening, they've made it through.
Yeah.
I know one guy in San Francisco that's going to be interested in this.
Okay, well, this is for you, one guy in San Francisco.
What? Yeah, what Cy will probably be interested in this.
Okay.
Well, just go. Tell us what. Tell us what you did.
One of my major research interests right now, and throughout my kind of master's, was what's called differential privacy, and it's a creation of a Microsoft kind of like skunkworks research lab that. In full honesty, Microsoft doesn't use. Apple is one of the only people who are like fully committed to it, which is why I buy Apple products. That's not sponsored by Apple.
Hey, we're still unsponsored,
I
man.
know. I'm just saying that, like, when they said that they committed to that, I was like, I'm on board. User privacy is awesome. So to explain what this is, it's a concept called differential privacy. And in any sort of database, the basic level of security is to anonymize a data set. So what that means is that they're going to have an entry for Elliott, but they're going to replace the words Elliott Whitling with a random ID number, often a global unique identifier. The problem with this global unique identifier is that if you start hitting multiple databases, you can actually reverse engineer somebody's information. And I did this with, there's this actually famous diabetes study with the Pima Indians. And what that is that they essentially took a whole bunch of women who either had children or were about to have children and checked them for type 2 diabetes. The Pima Indian people unfortunately have really high prevalence of diabetes, but they were able to build one of the earliest perceptron models. It's a I won't get into the details there. But they were able to build one of the earliest perceptron models to essentially predict if a woman was going to have diabetes.
It's pretty cool.
It was awesome.
Yeah.
The problem is that the way they anonymized the data was with an identifier. I built a web scraper that went through, I was about to say Amazon, Ancestry, and it built family trees for the Pima Indian population because unfortunately they're a relatively small population that don't leave their region very often, so they're very sequestered. And I was able to, out of the 600 participants, positively ID about 10 of them, mostly the people with outliers, like the people with a lot of children or something like that, and essentially go, well, I know this person is this based off of the attributes of the data set of, well, in 1973 they would have had this many kids, that's what it says in the database, and based off of Ancestry.com data, there's 2 people in this population and one of them is a male, so it's the female. So this is called a linkage attack. It's really popular. Don't do it for fun because it's very, very rude. But and to the Pima people, if anybody from Pima is listening, I destroyed my scraper and I do not have any remnants of your data except for the published data sets. And it's, I'm trying to be cool with that, at the same time nerd out. But the point is that differential privacy should protect you from that by essentially adding random noise each time you talk to the
And so what is differential privacy?
Differential privacy is this idea that every time an analyst asks, or anyone asks the database a question, the database gives you a slightly different answer. And so it will tell you a answer that has a bounded amount of noise on it based off of the entire data set. So if I asked it Elliott Whitling's age, the true answer is 29. But it might give it, based off of the population of the query you just asked, I'm going to tell the user 33. And the idea there is that there's a lot of math that gets way too deep for a podcast too fast, but the point is that it gives you answers that when used in aggregation are still useful to things like medical studies or useful for customer analytics or useful for really any learning model, but at the same time protects targeting, yeah, totally, but at the same time protects the individual from a CEO going, I want to know what's going on with my wife's medical history or my ex-wife's medical history. It really protects individuals.
So for example, like everyone knows the story of like someone who got a job because they like targeted someone hyper specifically on Facebook, right? Like I want this particular age group at this particular company at this, until the sample size is so small that you're going after that one person. And so I think that as we talk a lot, nerding out at night over wine, not necessarily on the podcast, there's this tension between like, wow, this is really cool targeting that we can do as marketers, but as individuals that's hyper creepy. And I don't really like that, there's that much data about me out in some database. Yeah.
Well, and so you're totally right. The drawback with differential privacy is that there's a very economical approach to it. And so you might get to a certain point where the database goes, too many questions have been asked about Elliott. I'm never going to return any more data about Elliott, which is great for the user, really bad for the company that poured millions of dollars in curating a data set, because it now means there's essentially putting a lifespan on their data, which I don't know any company, except for Apple, who is willing to do that. And so I'm really hoping that either we can have this culture shift that like, yeah, we actually need that, or that maybe there's kind of differential privacy 2.0 that can solve that problem for people, where it's like, yeah, we'll still give you answers about Elliott, but the answers are going to be vaguer and vaguer and vaguer until until we reset and then something happens where again he's anonymous.
It's almost interesting to take topic one that we were talking about, attribution vendors, where they're like kind of guessing about what's going on, and we made this offhand comment that's like, well, Google or Facebook would probably just know, right? And then this comment where it's like, okay, so if you're malicious and you're willing to query a database enough times, you can hone in on that particular person. It's like, okay, so attribution vendors are perhaps this like intermediate solution that's not going to stay around. Not that anything in internet marketing stays around that long, unless you're Google or Facebook. But
well, still give it time.
yeah, right. Look at where Yahoo is now. You know, like differential privacy actually may be the thing that people are talking about in terms of attribution, because it's like, well, how many times can you ask a question about a certain user and their behavior before the database locks you out on that user?
Right. Yeah. I've never heard of this, so it's pretty cool.
It's kind of an obscure topic, because even though Microsoft spent a ton of money pouring in, to pour into this, and a lot of effort, and like just absolutely brilliant researchers, to my knowledge, they haven't implemented it in any of their systems. They could be doing it and just not telling anybody.
Yep.
That's also very possible, but the only company that I know of that has publicly said we are doing this actively is Apple.
That's pretty cool.
Yeah.
That's really cool.
So, yeah, I hope more people learn about it, because if we start demanding it as consumers, it'll be good for everybody.
Yeah, and this is, you know, I think a lot of the discussions that you brought up were particularly around like medical technology, that kind of thing. But, you know, probably the marketing side of it is the more like direct attack on someone's like actual privacy. Yeah. Especially since a lot of the databases are like, well, it's anonymized.
Yeah.
Right.
Like your email's a hash.
Yeah. Right.
But it's
easy to break. I mean,
okay, so talk about that.
Well, okay, so email's a hash, right? Sure, you might not be able to find the entry.
So let's assume for a second you're not breaking the hash directly.
Yeah, because encryption, that's hard, right? Encryption is good. Use encryption, but I don't know how else to say that. But the point is that a lot of people's data is spread out across multiple databases and are not controlled by a single database entity. So what that means is that you can find my email address on LinkedIn, and if you can pair my United Healthcare data with my full name, Elliott Whitling, and then you put that onto LinkedIn, you now have the email address that I probably use.
So we're talking about things that are probably more advanced than this, but an example might be the adultery website.
Totally.
Yeah.
Oh, Ashley Madison?
Ashley Madison,
Yeah.
right?
Oh, yeah.
And then people start taking the passwords out of that and going and figuring out like who's who.
Yeah. There's actually a case of a full linkage attack that happened. I want to say that it was Massachusetts or one of those M states. Forgive me, I don't remember the particular example.
I don't know. They're all the same.
They're all the same. But essentially, a governor, his entire healthcare, he was going through some sort of healthcare crisis, and his entire healthcare records were leaked online because his residency was public domain information, and his healthcare information was leaked in a unencrypted database, but it was anonymized. But based off of doing several linkage attacks, somebody was able to be like, oh, hey, our governor has kidney disease, or whatever it is.
Jeez.
So it's not hard. Especially since there's databases everywhere.
Well, sleep tight, kids.
Yeah.
Yeah, I don't know. We can do a couple of quick hits. We're at 28 minutes right now, so we're probably like down to rapid fire.
The tryptophan's kicking in for me too.
Oh yeah, you actually have some turkey.
Yeah.
Okay. Well,
that's also probably why I'm so quiet right now, because I'm like, I had the brownie, so like I had a sugar high, now the tryptophan. I'm like,
you don't have to lie. I know that this is like pretty boring stuff.
No, it's actually really cool stuff.
Okay.
It's actually really cool stuff.
What's the difference between a data scientist and a data engineer?
Okay, so this gets into like what a lot of. This is a huge conversation. This is one that is not a quick hit.
But distill it down into like 30 seconds for me.
In Elliott Whitling's opinion, a data engineer is somebody who
Seth
builds...
Godinized this for me. Like so basic that it doesn't matter anymore.
Okay, the data engineer builds pipelines and storage for data. So what that means is, okay, the tweets come in, they go get stored here, they get stored like this so that there's fast indexing, and our data stores scale and connect. The data scientist, he or she might be doing something else like, okay, based off of those data stores, I'm doing something that goes beyond just your KPIs. It's a learning that has a massive amount of uncertainty to it. So you're so it kind of goes, data engineer, you need that to make sure your data exists.
Could that also be like a database administrator?
Totally could.
Yeah.
In a lot of companies, traditionally they're database administrators. I like to expand it out to data engineer because, for example, Twitter or Facebook, they have like column store data sets and graph databases as well as relational databases. So it kind of blows up to the skill set that is not just database administrator. They're doing like a lion's share of the work. There's the analyst who's going to be looking at your KPIs every day going like, hey, our books don't balance, or hey, we have low sales, things that are very certain based off your data. And then your data scientist, he or she is going to be looking at the data set and making inferences that are not 100% correct. There's going to be a lot of failures in those inferences. But if you have a fantastic data science team, they can also just change the world, like Netflix's prediction model of, oh, hey, you were watching Murder, She Wrote, you probably want to watch Luther next.
So the follow-up question would be like similar to one of the Q&As that we answered, which is like, should you insource or outsource your marketing management or something like that? So at what point in a business's life cycle, and granted that's like a super, generic question, but like at what point would you expect to have certain types of people in your organization?
You should have an analyst and engineer of some point day one. And that might be the same person, but if you don't understand your KPIs, then what are you doing? You're not driving your business with data. You're an insane person.
Hey, we've said that before.
Valid point. Yep.
I honestly, from the consulting I've done, a lot of companies bring in data scientists because it's a sexy title, and they want to say we have a data scientist on our team, and they don't need that. They need a data engineer and a data analyst. When you start building models that deal with a lot of uncertainty, that's when you need your data scientist, and you'll know that because you'll go, our analysts are only bringing back so much information. There's this thing that we want to do that we can't learn from the data we have.
So for the marketing audience, this might be going from understanding clickstream information. So it's like an analyst is going to help you say like, people bounce on this page, people convert here. It seems like changing this button color has improved conversion by X%, right? But your data scientist might help you say, based on a giant set of customer data, we can say that because these are our best customers, if we do these things, we can turn more customers into our best customers. So like a customer lifecycle management type model.
Totally. And to be honest, from what I've seen, you have to be relatively mature in your data sets for that. I unfortunately...
What does mature in your data sets mean?
It means that you have really reliable data that has gone through several iterations. It has not vertical scaling, excuse me. It scales in the type of data that comes into your databases, and also horizontal scale. I'm using the wrong terms here. I apologize.
To no one in our audience.
To no one in your audience that knows this. But,
sounds good to me.
But the point, I keep saying the wrong word, so I'm sorry. But essentially the point is that you have a wide variety of data, and at the same time, because your data scientist is going to need that, at the same time you have a large volume of data, and that your analyst is able to answer the questions they've been tasked with. I really think that, honestly, for most organizations that are kind of either in the startup or in the we're just trying to get our feet under us in the data world, an analyst is going to be way more return on investment for you than a data scientist. And probably if you hire a data scientist, they're going to be doing a data analyst's job until you have the infrastructure built. And that's, you could be saving a lot of money by not doing that.
Okay, so what is a large data set?
It varies from data type to data type. I mean, the data sets I do, we get maybe a terabyte of data in 10 minutes. So
that's large.
Yeah, but maybe we get at the same time, I would say once you start getting over like 1 billion rows in a relational database, you start getting into the large databases where you have to start doing things like database partitioning.
Right.
But it really depends on your database engineers, how your data warehouses are set up, because you might have a company like Walmart, for example, who might have like 50 years of transactional history, but really only the last 3 weeks matter, for example. And so really the data that
or let me ask you this, like they might have 50 years of data, but let's just, for the sake of simplicity, say it's over 1,000 SKUs. Now it's probably more like a million SKUs or something like that. But does that mean that, like, thinking about I'm thinking like square footage on a floor, but like, does that mean the database is not actually that large and not really that complicated?
Right. I mean, there's a lot of questions about this. And again, this is kind of gets down to like a case-by-case basis of what large is. Because like I just said, we generate a terabyte every 15 minutes or so. But
would it be fair to say it's not the size, it's how you use it?
That is well said.
Nailed it.
Because I was going to say...
Thank you, Zach, for showing up today.
You got it.
Yeah.
Mic drop.
Yeah, exactly.
That's why we have it on a stand, so you can't do that.
Yeah, so you can't drop it. But only, out of that terabyte, only 100, 120 megabytes of data is worthwhile.
Cool.
And so, varies.
Cool. How can people find you?
I just started a blog, Whitling, WHITLING.com is my awesome new WordPress blog. You can find me on Twitter. I don't know my Twitter handle, so go to my blog instead.
I like it.
And if you really love me, then, I don't know, find Chris and Zach and then get a hold of me.
Cool.
I'm selling myself well here.
I take a referral fee, just so you know.
That's okay.
All right.
A referral fee of $0 is...
That's not sponsorship.
Yeah.
Or is it?
Might be.
I think the FTC would call it sponsorship, but maybe marketers wouldn't call it sponsorship. That's like, it's not
whole other debate for another night.
Yeah, exactly. Yeah. Like we didn't take money up front, and you're not taking the risk like we are. So anyway, we can debate that some other time. All right, that's it. Thanks everyone for listening.
Thank you.
Bye.